As long as you can see what is happening, then it's okay. All right. Now just recap on the previous lecture. What have we done previously? Right. So we have gone through the example where yesterday class we learned something new where every time where we start with differential equation, we will move dy dx to the left hand side. Then after that, we add one more step where we move all the y to one side. Right? We move all the y in the equation to one side and move the x to another side. And then we continue with the rest of the steps that we learned so far. All right. So for example, the example that we see yesterday, right? Okay. So the steps will be you look at the equation, then you arrange it in the way where dy dx one side, and then the equation one side. After that, you look at the equation, move y to one side, x to one side. Okay. For example, this one, you see x one side, y one side. So it doesn't matter whether x on the left or right, but as long as you arrange your equation, x one side, y one side. Then after that, you get dy dx both side. You do integration. After the rest, after you put in the integration sign, the rest is just integration steps, like what we cover in chapter 2 and chapter 1. Okay. Now today we look at one more example. Then we go into a new example or new concept. Okay. We have gone through all this. All right. Now let's look at application of differential equation. All right. Application of differential equation. So I hope you can read something on the on my back here. So what we have here is we given a statement. So this statement is the variation of a resistance R ohm. So resistance, if you learn in your electronics module, you know that resistance is in the unit of ohm, R, of an aluminium conductor with temperature 0 degrees C, given by one differential equation, as you can see here on the second line here, dr over d theta equal to alpha r. You are given a differential equation. So alpha equal to blah, 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 and you're given the two value. If r equal to r naught when theta equal to c, 0 c. So remember, when you are given a two value, you are given the value of x and y, then the purpose is to get the c, the constant value in the integration. Okay, now this part, you convert what you see here into dy dx equation, right? You compare dy dx equation that like what we learned previously, right? Don't get frightened by the complex equation that you see here, right? So here, as you can see the equation on the second line far left there, you put your equation as dy dx, and then the left hand side you have alpha and r. So, and then the second one will be the second case lah. After we solve A, we solve B. So just an introduction to B. What is B? So once you solve A, you solve for B. So you're given the value of alpha, determine resistance at 50 degrees C. When resistance 0, you get ohm. So you're given all these value. Okay, we'll look into this part later. We solve the first one. So A, you are given the dr over d theta equal to alpha r. Look this equation, see this equation as dy over dx equal to something y. You can see the y and y. So what you do, first step is just move your equation, arrange your equation, dy dx one side, and then left out the equation. The second step is to move the same parameter on one side. For example, all the y into left hand side, all the x into right hand side. Okay, so this one, you rewrite the red color equation in form of this one. Okay, rearrange it, you get d theta equal to dr over alpha r. Okay, meaning after you rearrange in the first, you copy the equation from the question, and then you put in this term dy over dx equal to function. Doesn't matter lah. So the first step, always get dy dx first. So the question already give you in the dy dx form. So now after these steps, what you do, you move your d theta below 1, d theta to the right hand side, and then put the alpha r into left hand side. So that's why alpha r are below. So take note, Edmund, you are quite weak in this area. You need to pay more attention in this area. Okay, if you don't know how to move from this step to this step, go back to your engineering 1, maths 1 lecturer. Ask your lecturer, maths 1 lecturer, to teach you how to transfer this one to this one. Okay, so after you get theta one side, r one side, the rest is to add in the integration sign. So left integration, right integration. You get this symbol in your answer. So remember, although you didn't see anything here, the value is 1. So you integrate 1, you'll get the equation. So Nizam, what is integration of 1 d theta? What do you get?
X theta x.
This one. If you integrate dx, you get what?
Integrate dx 1.
No, if you integrate 1 dx, what do you get?
Integrate 1 x.
Then now this one change, x become theta. So integrate 1 d theta, what do you get? Okay, just now you say the correct answer. If you integrate
X theta x, right?
just now you integrate 1 dx, you get what?
1 dx x.
You get x, right? Now you change this one to theta. So you integrate 1 d theta, what do you get?
Theta x.
No.
No.
You use the same concept just now. You can do integration 1 dx, you get what?
1 dx is x.
X. Why you get x? Because you dx what?
Okay. So the theta?
Now
theta is
now
x. Okay.
now what you get? Now what you get? You integrate 1 d theta, what you get? You just change the x.
Squared.
No, now you only change the d theta, what do you get?
Only change theta.
Okay. Now I back to the same question. The integrate 1 dx you can do. Integrate 1 dx, what you get? You get x, right?
X, yeah.
Now you only change the parameter here. You change the x to what? To theta what? So you integrate 1 d theta, what do you get? You integrate 1 dx, you get x. Now you change the d theta, what do you get?
X.
Is there any x? What do you have here? What do you have here?
I don't know.
Theta, you have an angle here. Or not angle, is you have a temperature here. When you dx, you get x. When you dy, you get y. When you d angle, what you get? Or d temperature, what you get?
Only angle.
You get the angle lah. Not angle lah, but in this case is theta. In this case is temperature lah. Okay, so this one you integrate, you get theta. So this side is your expert Nizam. You integrate 1 over alpha r dr. What do you get?
1 over.
You get this one is constant value, correct? 1 over alpha you pull outside, you get this one. So this part I think you expert already. Integrate 1 over r dr. What do you get?
Integrate 1 over r. 1.
Okay. I changed the r to x. Integrate 1 over x dx. What do you get?
Ln x.
Okay, now I change the x to r. So
ln r,
integrate 1 over r, the r, what you get?
ln r.
Ln r. So you can do, right? So this one also same. Just now I changed the theta. The x you can do, but I changed the theta, you cannot do already. So I don't know why lah. So same thing, same principle, only change the
So, yeah, if I get confused like that, can I do like dy dx first? If I, let's say I write beside that dr equal to dy and then d theta equal to
can,
dx. Can I
then
do
after that you substitute back also can. If you confuse like that, you can substitute. At the end, you still give me the answer in theta and r. If this question come up, can no problem. Okay, yeah. If you confuse with all these special symbol here, then you do dy dx also can. But you write in this formula, you have to, in your answer, you have to write dr equal to dx, d theta equal to dx, then you do dy dx, then you do. But you have to change the question. The alpha r, the r have to be y lah. Alpha y lah. Nizam, do you see that?
Yeah.
If you change the r become dy, so your r must be y lah.
Okay.
So you have to write alpha y lah. So actually same thing. So again, integration something, integration 1 d theta, you get back the same thing, the same parameter here, theta. If you integration 1 dx, you get x, because 1 you add x ma. So same thing. Then this one you can do, but only when I change the x into r, you cannot do. So you have to practice more, then you can do already. So this one same. Always when you do integration, if you see a constant value, for example 1 over alpha here, you need to, I recommend you to pull outside the integration. For example, from here to here, I pull 1 over alpha outside first, because 1 over alpha is a constant value. Okay, so be careful. This is under denominator. This is under there, right? So top and bottom. So this one is, when you pull this one outside, remember, don't only pull alpha. Alpha in this equation here is 1 over alpha. That's why when I pull alpha from bottom, I pull outside, I get 1 over alpha. Okay, now this is a reminder for Edmund. So Edmund, this is your weakness. So remember, when you pull constant value outside, remember to see carefully whether it's a full number or it's a fraction number. If it's a fraction number, when you pull outside in this example, your alpha is 1 over alpha, right? So you get this one. So how to get C? How to get C? The answer already given to you. The C, how you get? Because when it give you the 2 number there. So it give you when r equals something, theta equal to what? You substitute these 2 number inside here, you get your C. Okay, how to get C? I show you. So this one given in the question. So when r equal to r theta, when r equal to r0, when your temperature theta equal to 0 degrees C. So this basically, in your equation here, you have your temperature and your r. So this one given in the question. So you just substitute this one inside here. Then this one inside here. So the whole equation, you only left out C. Alpha is something alpha lah. It's just a constant value. You don't touch it. So you rearrange the equation. Okay, you rearrange equation. I just straight away. I don't do the steps for you. When you substitute, you rearrange, you get your C equal to minus 1 over alpha ln R0. Edmund, you able to understand why suddenly you get this C equal to negative something?
Oh, yes, sir.
Okay. Shakir, you okay? From here to here? Shakir, you okay? Shakir, are you there? Nizam, you okay, right? From here to here.
Yeah, okay.
All right. So again, this is a bonus, can say bonus mark already, because the question they give you the 2 number, and then the purpose, the question give you these two numbers is to find C. So the only challenges is that when you substitute the value, some student they will take out some value from here. So just be careful on that. Right? So when you have the C, what you do, you substitute back here and rewrite the equation. So you will get theta, because your C here is negative 1 over alpha ln R0. So you rewrite this one inside here, you get a negative here. So alpha equal to 1 over alpha ln R minus 1 over alpha ln R theta. So in exam or test, if you give this answer, I will still give you correct. So if the question asks you to give me in the simplified form, so meaning you have to continue solving your ln in the bracket. How you solve? You factor it out. So in here, you know that 1 over alpha is between two term there, right? You have 1 over alpha here and 1 over alpha here, because your C is here. So you factor the 1 over alpha, you get this one. So ln R minus ln R0, ln minus ln, it become what, Nizam? You take ln minus ln, what do you get?
Divide R over R.
Correct. You get ln R divided by R0. So again, remind yourself, we are practicing what you learned in Max 1. You convert this one into this one. Okay. Then this is the simplified answer. You can put in this form, or you can pull the alpha to another side in this form. Okay. All right. So in test, you can arrive at this step if you ask to give in a simplified form. You can arrive at here, but for B, you need this form. For B, let's solve for B. So okay. So here again, you can change the ln. You can change the ln equation. Theta alpha equal to ln R divided by R. You can change to E something form. So for example, you compare this one and this one. So this one is the ln chapter. You transfer ln into E power something. If you remove the ln, it will convert to E theta alpha equal to R divided by R naught, or R0. Okay, so here to here. So this one also I show you in the previous example already. So we have one example. Then we put them in the R term, because the question asks you to solve the equation for R. Solve the equation for R. What does it mean? What's the question want you to do? It wants you to put your equation, right? The equation that you get from here, put your R on the left hand side. Means you rearrange this equation, put your R in the left hand side. This is the meaning of the question. Solve the equation for R means once you get one equation, rearrange the equation according to the question. The question asks in this one, question asks you to solve for R, meaning you rearrange this equation, put your R on the left hand side. So these are the steps you rearrange, and you arrange it here. R equal to R naught E power theta alpha. So mean you move this one to left hand side, you get your R. Yeah. So these are the keyword that are important for you to score some marks for your coming test 1 and also final exam. Okay. Once you have this one, it asks you to solve for the second one. So second one give you the value of alpha, meaning you substitute this value alpha over here, and you are given to solve resistance, to means solve this one at 50 degrees C, when the resistance at 0 degrees C is 24 ohm. So what does this statement help you? So you have this equation, and I'm going to do something over here. So if it give you extra information, so at okay, R naught, R naught, what does it mean? R naught means 0 degrees C. in the section A, it tell you R equal to R naught when your temperature equal to 0 degrees C. So what you do, this is the resistance at 0 degrees C. So it give you already resistance at 0 degrees C with this one. It give you 24 ohm, means you substitute 24 ohm here. That's why you can substitute R naught equal to 24 here. Because in section A, it tell you what is the value of R when the temperature is 0 degrees C. It's R naught. So the original is R naught. Then B, it give you the value of R naught. So read the statement. This one means that you need to relate to A. So resistance at 0 C, what is 0 C is your R naught. So R naught at 0 degrees C is 24 ohm. So you substitute this one, 24. Okay, 24 E power, it asks you the temperature at 50 degrees C. 50 degrees C, so this one is the temperature. So it gives you 50. So you substitute this one as 50 here. So this, you can press your calculator to calculate. So again, if you don't know how to use calculator to solve this one, go and read your calculator manual. Okay. So this one, you press your calculator. Don't be surprised. There will be someone who don't know how to use calculator to calculate this one. Okay. If you don't know, go and read your calculator manual. Okay. So the answer for this question is 29.0 ohm. Okay, 29.0 ohm. Okay, let's learn a new things after this example. So if you look at the equation and you can write in the two function, like for example this one, x and y, what do? You can use this method. So if you're having a dy dx equal to function x function y, you can use this method. Okay. So the same steps, the same steps. What you do if you're having the two function, meaning you can factor it x and factor it y. What you do also same. First step, when you see differential equation, arrange dy dx one side. But don't care anything else first. First step, you look at dy dx, you pull your dy dx one side, and then you let the equation on the another side. Then you try the first method like we learned just now. If cannot solve, you use the second method. You move your y to one side, x to one side. So this one, we add one more scenario where it's just the same principle. After you get dy dx, you pull one side, all the y to one side, all the x to one side. Just now, all the example before this is you pull the y to one side, right? So this one I add on one more x function there. So means you just continue with the procedure that we learned. You pull y to one side, x to one side, and then you continue with the integration steps. I'll give you one example. Okay, so example number 8. Solve dy dx, solve 4xy dy dx equal to y square minus 1. Edmund, what is the first step when you see this kind of equation?
dy dx, different equation.
Okay, first step is you put your dy dx in one side first. Okay, now Edmund, what is dy dx? Solve for dy dx for me first. Dy dx equal to what?
Y square minus 1 over 4xy.
Divided by 4xy. Correct. That is the first step that I expect from you in exam or final exam, or in test or final exam. Okay, first step, you look at the question, you know already, you see dy dx means is under differential equation chapter. It's under chapter 3. Chapter 3 for differential equation. So first step, move your dy dx one side first, then the rest it doesn't care first. Right? You move your dy dx one side, then only you look at the equation. Okay, you rewrite this one. Okay, if you don't understand this one, never mind. Only you know that the steps is you have to put dy dx one side, and then after that you pull. If you pull your y to left hand side, if you dy dx, if your y is on the top, put all the y on the left, then you pull your dx to the right hand side, pull all your x to the right hand side. For example, this is an example. So just now Edmund give us an answer. So what you do, you rewrite the equation in this form. Right, this one comes from the dy dx, and then you make it into a linear equation. Means you iron it out, become one straight line equation. Okay, this one I pull the dx to the right hand side first. Then I arrange the equation. Because I know that my y is one side, my y is on the left, my x is one side. So what I do, I will park my y to left hand side. This one I will factor out later on. Then when I factor out, I pull my x to left hand side. For example, this one. Okay, so what I do, I pull my x. Okay, I pull my x to right hand side. So 4xy is a multiplication. I know that my right hand side is x, dx. So I pull my x to right hand side. So I divide this side with x. Okay. So after that, my left hand side I see y already, okay already. But on the left hand side I still see y. So I need to move this whole set to left hand side because this area belongs to x. So y cannot enter. So we have to move y square minus 1, this whole set, to left hand side. You get this one, okay? The main purpose for this kind of equation is to get this kind of form where dy and y one side, dx and x one side. Make it clean, meaning there's no mixing of y over here, there's no mixing of x over here. Okay, so first step, write your equation in dy dx. After that, move all your y, or you arrange the equation first. Move all your y to left hand side, move all your x to right hand side. I remember these steps because the equation in the exam or test will be changing. Just try to understand the strategy we use to solve. After you get this one, you continue with the normal integration that we learned before this. Because you are seeing linear equation here, you're seeing dy, you're seeing dx. What you do next is just add the integration sign in front, then continue to do integration. Okay, so this step to this step automatic. You should know when you see dy one side, dx one side, automatic. These steps onwards, don't need to tell one. You just add an integration sign and do the integration. Okay. So again, I will not repeat the step over here. You already become expert already. So I'll be giving you some tips there. I will use the U and V, or you can use the quotient rules to solve any method that you feel comfortable. In this case, I use U to replace this one. I use to replace this one. So I use U equal to y squared minus 1. So once I have U, there must be a du dy. In this case, because your U is y, not x. So once you use U equal to y something, the next step will be du dy. Okay, so du dy, you get 2y. And here, because of you are replacing this one dy, so you need to rearrange du dy equal to 2y in the form of dy. So you rearrange, you get dy equal to du divided by 2y, because you're going to substitute this one in terms of u. Okay, so this one, with this method, this side will become this one. I put in blue color just to differentiate the method. So this one in the bracket one already become u because you substitute the bracket one with u, and dy we already do the conversion, right? From the u equation, we know that dy we can substitute as du divided by 2y. Okay, so from here you can further simplify. You can take out the y, 2 and 4 you can simplify, right? So there's a 2 here after you simplify. After you simplify, you get 2 u du. So there's no more y inside. Okay. Then, of course, here, I don't need to explain. This one, Nizam already expert. So integrate 1 over x dx, you get ln x. So if you don't understand this one, go and ask Nizam. This one, we're going to explain to you. This one. Okay. So this one, you get ln x. Remember, when you don't see anything at the integration here, remember there's a c there. So ln x plus c on the right hand side, and then this one also same. So you have a constant value, pull 2 outside. When you pull 2 outside, you will be getting 1 over u du. Same concept as this one, but now it's u. So you get ln u. Okay, I pull my 2 outside. I get 1 over u du. You practice the same concept. This one become ln u. Okay, this whole thing, this component become ln u. So remember, after you get this one, remember to substitute back what is your u originally, because the question don't have u. So you need to substitute back what is your u earlier. Substitute a u here. You get the first stage of your answer. This is called general solution, where you need to find your c. In this case, there's no extra information here. You're not given the x when x equal to what, y equal to what. You're not given the y and x value. So you left your answer in C. If you're given the value of x and y, then you can substitute inside here. Inside here, you get your C. Then after that, you substitute back. You get the full answer, specific solution. Any question for example number 8? Any question? Shakir, you okay? Shakir, are you there? Nizam, are you there?
Yes, sir.
Okay, Nizam, any question?
No, sir.
Okay, all right. What happened to Shakir? Let me check. Shakir, are you there? Shakir, please respond if you can hear me. Okay. All right, let's continue. So again, if the question asks you to put in the simplified form, then you need to convert the ln in the e power x format. So how do you put in e power x format? You pull the two ln together. So again, in front of ln, if there is a constant value, you can pull this one and put at the back of the column. So in this case, so 2 you pull to the back of the column, you get bracket power 2, and then you put your ln and ln together. So this one to this one is negative. So you get 1 over ln y square minus 1 square negative ln x. And you get your c. So you know how to convert this one, right? So ln something minus something means divide. So you simplify this one only ln this one divided by this one. Then you get your c. Convert this one in terms of e. So this one equal to e power c. Okay. Convert this one in terms of ex. or this one is C lah, because this one, when you write in the EX format, it will become this one. Okay. So let's say if the question give you extra information, this is just an extra step lah. So what happens if the question give you C equal to something? So C equal to ln A, you substitute ln A here. So you just back to the previous steps lah. If C is given, then you continue with the ln steps here. For example, this one. Right, ln step here. So I will just use this one. So you substitute your ln A equal to C here. Then you have ln, right? When you have a ln equal to ln, both sides you have ln, what do? You just take out the ln. Okay, if both sides you arrive at ln and ln, you don't need to move already. You just slash the ln. The answer is this one. Yeah? Recall the operation of ln. When you can slash, when you cannot slash, you have to be clear. You can only slash the ln when both sides there's a ln and nothing extra here. There's nothing extra here. For example, this case, if some ln something equal to ln plus something, there's something here that you still need to solve. You cannot slash. You cannot take out the ln. Edmund, this one you need to be careful. Don't slash when you have something in the equation here. You can only take out the ln when you are clean on both sides. For example, this one. Both sides don't have anything. So you can slash the ln. This will be the final answer. Okay? So then you rearrange. You put in this form. Of course, this one and this one is the same. It depends on what the question wants you to solve. Okay. Now we go for example number 9. Okay, we go for example number 9. Let's see if you're able to do with the method that we just learned. So you are given a solution d theta dt equal to something. Given t equal to 0 when theta 0. So remember, when you're given extra, this one is to solve the c, the constant value, in the integration later on. Okay? So, first step. Edmund, what is the first step? When you solve this one, what is the first step?
Rearrange.
Edmund, what is your answer? Can you repeat? What is the first step?
Put the T one side.
T what?
The T to left hand side.
Put T. Put what to one side?
The d theta over dt.
Put the theta over the t one side. Or you can say like Nizam, he confused every time, got extra special symbol. Then you put dy dx one side. Okay, no problem. So rewrite the equation. Already put in the dy dx form. The next one is to adjust accordingly. So in this case, you put theta one side, t one side. Means you put y one side, x one side lah. Okay, you look at the equation. So this one is to test your understanding in the E equation, exponential equation, E power something. All right, so here, 2e power 3t minus 2 theta, actually you can write in this form. You can break this one into these two equations. So you can break 2, put one side, and look at e power 3t minus 2t is basically e power 3t multiply by minus 2t. So you get this one. Okay, e power 3t multiply by e minus 2 theta. Basically, it's a plus lah. So 2t plus minus 2 theta, you get this one. Again, if you don't understand this step to this step, go and call your mathematics 1 lecturer. I expect you to know already. So I'm not going to explain how to get from here to here. Okay, call your max 1 lecturer. Huh? So after that, what do you do? After you get dy dx and the equation, again, pull your y one side, x one side. So here, which one is the, you know that this one, you pull your dt to right hand side. You put this one to right hand side. So right hand side is dt, so you remain the dt one side. Then you pull this one theta to left hand side. Again, when you pull, you must know the the relationship. These two are multiplication. So when you pull multiplication one side to another side, it becomes division. It becomes divide. Huh? So you will get this one. Okay. So here to here. So you pull this one. Again, you pull this one is a multiply. So you from the right you multiply. You move to the left, you divide. So this one become divide. And this one you continue to write 2e power 3t dt, you pull to the right, you get this one. Continue from here is the same, where you solve for integration steps. I think the challenge is read the question and convert in the form that you can put one side and one side. That is the challenge. And that one you need to do more example. Okay. I will give you the example in assignment, right? So you need to pass out assignment later on. After that, you rearrange the equation. 1 over e minus 2e. What is something minus? Exponential means if you x minus 1, what does it mean? If you have x minus 1, it is the meaning is 1 over x, right? So what? So you remove the negative here. You convert into the form that you're familiar. You remove the t, what do you get? 1 over e power 2 theta. You remove the negative sign. Huh? You remove the negative sign, you get 1 over e over 2t. So 1 divided by 1 over 2e theta. You flip to upside, you get e power 2 theta d theta. Make this as your homework. Go and understand why suddenly there's a negative sign. When you rewrite this one, you can become this one. Okay, this one is your homework. Okay, you already passed your maths one, so you should know how to do this one to this one. Okay, so after that you get this one. The rest is integration. So you put it integration side, integration sign. Integrate this one, integrate this one. So there's a table to integrate this one. I give you earlier in chapter 2. Make full use of the table. So this one, when you integrate, you still get back the same. But again, remember, when you integrate something with power, remember that this is still have theta, right? This one still have theta. Remember to go in and integrate that one more time. That's why you get 1 over 2 e2 theta. Okay. So there's a textbook to teach you how to convert this kind of equation into this one. So go and read your advanced mathematics textbook here to here. This one, we already touched this one in the chapter 2. So you pull your 2 outside because it's a constant value. You don't want to confuse ourselves. Pull your 2 outside. You're integrating e power 2t. So again, there will be a textbook or in the chapter 2 table that I give you already tell you how to integrate e power something. So this one, integrate e power 2t dt, you can get 1 over 3 e 3t plus c. Why there's a 2 there? 2 is the original, 2 you pull outside. Okay, once you get this one, you use the question information t0 theta 0 to solve c, because inside here you have theta, you have t. You substitute 0 0 here, 0 0 here, you get your c. Okay, I do the small step for you. E power 0 you get 1, e power 0 you get 1. Simple mathematics, addition and division, subtraction. You get negative 1 over 6 equal to c. Remember to substitute back to original equation. You become this one. Put in the simplest form. You see 1 over 2 equal to 1, 2 over 3 equal to 1 over 6. Try to write in the more simpler form. This is a fraction. Remove the fraction. How you remove the fraction in this whole? You multiply both sides by the biggest denominator. You multiply one side by 6, multiply these two by 6, you get 3e something. This one multiplied by 6, you get 4. This one multiplied by 6, you get 1. Okay, so this is the final answer. Okay, example 10, I treat it as your homework. This is an extra example for you. So go and look at this example.
Sir, can you
Yes.
just like
This one.
wait.
Any question?
Just writing down.
Oh, okay.
Okay.
All right. So you guys can continue or give us need a break. Can continue? You guys can continue. We're going to end before 1:30 today. Another half an hour. Can you guys continue? Yes? Nizam, you okay? Or you need break?
Can I get a coffee first?
Yeah. Okay, so again, example 10, your homework. All the answer is there already. So you go and try example 10. If you can solve example 10 means you understand. Okay? All right. We'll move fast. Okay. Now we're going to solve a homogeneous first order differential equation. What mean by homogeneous? Okay. Why do we learn homogeneous first order differentiation? Because in your engineering or you learn about economics or other subject later on, you're going to use this one, right? So these are all the example, especially you deal with the thermodynamics, convection, conduction that you learn in your introduction to thermodynamics, fluid mechanics when you take your degree later on, heat transfer and so on. Anyway, you need to teach you to recognize when you look at the question, you know, oh, this one fall under what? Okay, so if you are given an equation, let's say function dy dx equal to function. So you have two functions here. Okay, function something dy dx equal to function. If you have the same degree, mean both sides, you compare to left hand side, right hand side, same degree. I already teach you in the previous class how to identify degree. We have second order, we have the first order, second order, and degree in our previous class. So if you forget, go back to the previous video. If both sides have the same degree, if you look at the whole equation, you look at the highest power inside the equation, both sides is the same, right? It must be the same order. then it must be in the same order, also same degree. Then we say as a homogeneous. For example, this one, this equation, for example, this equation, this function in x and y is homogeneous equation. Why? Why homogeneous? Because this one is power 2, this one power 2, this one, is it over 2 or not? Okay. This is x times x. This is y times y. This is xy. Basically, it's the same degree because you're taking two x's to multiply together. So x times x, you get 2. Xy also 2. Y square also 2. This is homogeneous equation. Okay. This one is not a homogeneous equation. Why? If you check the above one homogeneous means the same degree. This is 2, this is also 2, this is also 2. Okay, why this one is 2? Because you are taking x multiplied by y. Basically, you are taking two parameter multiplied by together. This one also same. You take x multiplied by x. Basically, you take two unknown multiplied together. This one also same. But this one is not homogeneous. Can you see the difference? Why we say this one is not homogeneous? Can you see something wrong with this equation compared to this one? Edmund, can you see the difference? Why I say this one is not homogeneous and this one is homogeneous? Okay, I explain one more time. What is homogeneous? You look at the equation, you compare the highest degree or highest power in the equation. This one is 2. This one also 2. But how we know that this one is also 2? Because you take two parameter, A multiplied by B. Basically, you take A multiplied by B. It's two things. So this one also, you take A multiplied by A, also two things. This one y squared, also B multiplied by B, also two things. So degree is 2. But this one y, why this one is not homogeneous? Something wrong that doesn't meet the definition of homogeneous just now. Do you see anything different from above?
Yeah, I got the y one only, no square.
Yes, correct. This one only 1. The degree doesn't same. So this one is not homogeneous. So when it's not homogeneous, the equation in this chapter onwards, you cannot use. Again, I repeat. The method that we speak in these slides onwards in under 3.1, when you talk about homogeneous solution, if you see the equation that in this form or not in homogeneous, doesn't same degree, then the method cannot use. You have to use another method that I'll teach you later. Okay? First, ask yourself, do you know what is homogeneous or not? The degree must be the same. If this one 3, x power 3, this one to become homogeneous, it must be 3 power 3 multiplied by x, y, z, or 3 power x power 2, y, or x multiplied by y power 2, the total must be 3, and y power 3 to become homogeneous. Edmund, do you understand what I'm talking about?
Yes, sir.
Do you see what is the why this one not homogeneous? Edmund, you understand?
Yes, sir.
Why? Can you explain?
Then the y.
Which y? You have two y here.
Negative y.
This one. What happened to this y? What?
The same degree.
What is the degree of this y?
Power 1.
1. So it's what? What degree? Degree of what?
EB2.
Degree 2 is this one. I'm asking about this one.
Or degree 1.
Degree 1. So here, again, if fall under homogeneous, it must be the same degree. So if you see this one, after this, the step that I teach you after this cannot be used for something like this. After these slides, what you see, the steps that I teach you to solve is for homogeneous first order differentiation equation. Homogeneous, it must be homogeneous and first order. What I mean by first order? Means your dy over dx is first order. Okay. If your d square y divided by dx square means you differentiate 2 times, it becomes second order. So that one later I teach you how to solve that one. Okay. So again, ask yourself, do you understand what is homogeneous or not? Do you understand what is homogeneous equation or not? That is the first thing before you move on. If not, you're going to confuse later on. Okay, ask yourself, do you understand what is homogeneous or not? If yes, then you can continue. Okay, this note lah. Okay, now I give you the step to solve this kind of equation. Homogeneous one, homogeneous first order differentiation. I give you step by step. First, same thing. Every time you see differential equation, write in dy dx first. You doesn't care how it looks. That you put the equation in dy dx one side, then the rest you rearrange the equation on another side. Okay, you pull the equation, you arrange the equation, you must see dy dx one side. Then another one is the equation. That one later on, step number 2. Again, differential equation, the first step always same. Write your equation in dy over dx one side, put on the left hand side. Then right hand side, you rearrange the equation accordingly. Next, we will use product rule. I'll give you an example, this one, right? This one later, if you do more example, then you come back to these slides. Just remember, after dy dx, you use product rules. I will show you the steps. Third, you do substitution. I will show you with one example. Then after that, you come back to these slides. And you continue to solve for the unknown. Okay? I'll give you one example. How to solve homogeneous equation. Example 11. You look at the question. Ask yourself, is this homogeneous equation? You have y minus x equal to x dy dx. Nizam, why this equation is homogeneous equation?
Because all power of no power.
No power? How can no power have power 1?
Of
Power 1. If no power, 0 is 1. Okay. So all the maximum exponential are y power 1 minus x power 1 and x power 1 also. And this one is first order because dy dx is first order. So first step, when you solve differential, as we learn more and more, there will be a standard steps. You follow the standard step. So you look at the equation, ask yourself, is this a homogeneous equation? Today you learn one more extra step. Means you analyze, you look at the question, ask whether this one is homogeneous or not. If this one homogeneous, quickly flip your notes. You open the notes for homogeneous equation. Then you look, then you follow the step. Then you solve already. Okay. You look at the question, look at the equation, ask yourself, is this a homogeneous equation or not? If yes, then you use the step that I teach you now. So the first step is to put dy dx one side. Okay, Edmund, you look at the equation given, y minus x equal x dy dx. What is dy dx equation that you can write?
Y minus s over x.
Okay, correct, but you have to put in bracket, Edmund, right? x minus y minus x bracket divided by x equal to dy dx. Okay, this is the from the question. First step, put dy dx one side. You get this one. Okay, always same, for it apply to all differential equation. First step, always same. Next, what you do if this one is homogeneous, you check lah. After you move, you check again. This one homogeneous or not? Yes. 1, 1, 1, 1. It can be 2, 2, 2, 2, or 3, 3, 3, 3, or 4, 4, 4, 4. Or it must be the same. The power above the number must be the same. Okay. Then this one is a first degree, first order differentiation. Okay. Number 2 steps. Ignore the red color first. Then you read back if you understand or not. Okay. What we do after these steps, what we do, we will write something like this on your answer sheet. You always start with the second step. Once it's homogeneous, the next step you write y equal to vx. This one is something new today. You write y equal to vx. After this step, you write y equal to vx. Next, you do differentiation from that side. You do on your answer sheet. You write after this step, after you arrange and you check is homogeneous. Next step, always standard. This is the standard steps, always same one. So after this one, you write y equal to vx, and then you do dy dx. Means you differentiate v and x. So what you do, the first one is actually is a product rules. So if you forget already product rules, go back to the previous lecture and video, go and watch again. So the first one, you get v dx, you get v times 1, this one, because you are using the product rules. So the first one, v dx over dx, you get 1. Then the next one is x dv dx, product rules. You get this one. You get x dv dx. Okay, this is the product rules. That what we learned in chapter 2 is what we learned. Then what you do, you rewrite your dy dx in one side. Okay. So you have, okay, step 1, you put your dy dx one side. This is the same for all differential equation. Check homogeneous or not. If yes, continue. You writing same one, same one if for homogeneous differentiation. You write y equal to vx, and then you write dy dx equal to v plus x dv dx. If you forget how to do, you just copy this one and put your answer, because this one always same one for homogeneous. It doesn't change one, always same. Then you substitute your y value here, y equal to vx, in your equation. Because in this one, your y, you have a y there, you substitute equal to vx. Yeah, after you do these steps, you check homogeneous, you continue with this step standard already, you just copy into your answer. This one, if you write, you get 1 mark here. And you continue looking at, next step is to substitute your y value, because we want to eliminate your y in the equation. You want to make the whole equation on the right in terms of x. You want to make all inside here is x. So how we eliminate your y? You substitute your y equal to vx. So this one, your y become vx. Next steps, you continue factor out the x. You doesn't touch on left hand side. You just continue. Y become vx. So you factor your x outside. You get x bracket v minus 1. Any questions so far up to this stage? Shakir, you okay? Shakir, are you there? Nizam, you okay?
Yeah, okay, sir.
Okay, good. Edmund, you okay?
Okay, sir.
All right. So after these steps, what we do, you cancel, you, after these steps, it depends on question. After these steps, you simplify the equation. So in this case, we can simplify it with x divided by x. You only left out v minus 1. So, and after you get this one right, after you get dy dx equal to something in term of v, after that, you put side by side this one and this equation side by side. I put side by side for you. After this step, after you convert your y equal to v something, you rearrange, cancel all whatever you can cancel. Then you will see that your equation will be in terms of v something. So you put side by side. Do you see there's the same thing inside here? dy dx, dy dx, v minus 1 and plus x dv dx. So you from here you know what is your x dv dx, right? Edmund, what is x dv dx if you compare side by side?
1.
Are you sure it's 1? Positive x dv dx. This one is what?
Minus 1.
So x dv dx equal to minus 1. Edmund, don't make this mistake again. All right. So try to improve on all this. When you compare side by side, don't just copy the value only. You have to be careful on the positive negative sign. So this one equal to negative 1. Okay. So if you put side by side and you put them together, you can either cancel the v. You cancel the v, so your x dv dx equal to minus 1. Okay, you can do direct comparison, or you can put 2 equal this whole set equal to this whole set. Then you arrange, you'll get what is your x dv dx. In this case, it's minus 1. Again, don't forget a negative sign. Okay, we have cleared the first steps. We have cleared the second steps, where our purpose is to get what is our x dv dx equal to minus 1. You rearrange, put your v one side, x one side. After you get what is this one, what you do, you pull your v one side, x one side in this case. So v stay, the x to right hand side, x multiplied by dv is a multiplication. When it's multiplication, you move, it become division. So from here, continue. So minus 1 multiplied by 1 over x dx. And here, you know that every time you see dv one side, dx one side, or dy one side, dx one side, the next step is integration. Right? Automatic one. This one automatic one. When you learn about max 2, automatic one. This one, when you see this one, you know already next step will be integration. Okay, same, apply to all cases. Once you arrive at dv one side, dx one side, or dy one side, dx one side, or d theta one side, dt one side, as long as you see d something equal to d something, your hand must be able to write the next steps. Will be you add in the integration sign. So again, Nizam, I like to ask you this question. Integrate 1 over dv, what do you get? Nizam? What do you get? Integrate 1 dv, what do you get?
V.
Okay, now you learn it already. Okay, integrate 1 dv, you get v. Okay, then this one I think you expert already, Nizam. What do you get?
Negative ln x.
Correct. So this one you get ln x. Again, integrate something divided by something, x 1 over x ke, 1 over p ke, you get ln. So here you get v equal to ln x plus c. How to solve c? How to solve c? Using the information given. Again, how to solve c? Always the same. Go back to the question. Go and find what is your x, what is your y. Substitute inside there. But you say, sir, Dr. Ang, I don't know where is x and y just now. But you still remember what is your v just now? You still remember what is your y you write just now? When you substitute in the second stage there, second step, you are using y equal to vx. So what you do, your v equal to what? Your v equal to y divided by x. Substitute back to this equation. So here you transform your v back to y divided by x. And you can use these two numbers, x and y, substitute back here. Y and x here, you can find your c. Okay? So I let you to calculate the c. I do some step for you lah. You substitute 2, 1 divided by minus ln 1. Your answer is 2. Because ln 1 equal to 0. Okay, you get 2. After you get c, what do you do? Substitute back here. Okay, you get your y divided by x equal to minus ln x plus 2. Okay. Then rearrange. Get in terms of, okay, if your answer arrive at here, do you get the full mark or not? The answer is yes. However, if the question asks you in terms of solving for y, then you need to write your answer y at the left hand side. If the question here, it asks you solving for y, I add one more line here. If the question add one more line, solving for y solution, meaning the question expect you to write only y on the left hand side. So you need to rearrange the equation, pull your x to the right hand side, you get this one, and this is the answer. If the question says something like give solution for y, then you write in this form and not this form. Okay, either one give you same mark. Okay, let's do one more example, then we call it a day. Okay, remember the previous steps? Just recap. You apply the same one. See if you're able to see the pattern. I'll repeat the same steps. First, you look at the question, ask yourself, is this a homogeneous equation or not? Do you understand what is homogeneous? If yes, continue. First steps, rewrite your dy dx one side. Rearrange the equation. Put your dy dx one side. Next step, don't need to think on. If this one is homogeneous, copy these two equations into your answer sheet. Write y equal to vx, and then you do product rules, differentiation, dy dx equal to v plus x dv dx. Basically, it's a product rules. After you do that, you move back to your answer sheet. Next step, substitute your y. Substitute your y with vx. They apply to all questions in homogeneous. Substitute your y. The purpose is to clear your y. We don't want to see y in our equation. Clear out your y. You solve. Until one stage, you only see v something. You see until one stage, you see v something. After you see this one, what you do, you compare side by side. You pull the second equation, put side by side, compare side by side. The purpose is to see what is this one. The purpose is to see what is x dv dx. So in this case, dv dx equal to minus 1. Again, be careful on the negative sign. After you get this one, The purpose is to integrate this one. You pull your dv one side, dx one side, put in integration, you'll get what is your v. V equal to something plus c. How to solve c? Go back to the question, look for x equal to what, y equal to what, substitute inside there, solve for c. Again, how to find v? Don't forget previous step, you already say y equal to something. So substitute back what is your v. And this step always the same. After you see v, the next step you see y divided by x because you substitute y equal to vx. Substitute x and y here, solve for c. So you get the c, rewrite one more time, you get the answer. And look the question carefully. If the question asks you to solve for something, solve for y means on the left hand side, you have to write y only. Okay, this one is solve for y solution. Okay. Okay, we go for example 12 quickly, just to summarize what we learned today. First, look at the question. He asks you to solve for this equation. You are given y and x value. Again, this y and x value is to solve c value. First, look at the question. Does this one is homogeneous? Is this one homogeneous or not?
No, sir.
No. Okay. Check carefully. First step, you rewrite dy dx first. Dy dx equal what? And then check homogeneous.
Yeah, it is homogeneous because it will be xy.
Yes. So if you write at the question, first impression, yes, I agree with you, it's not. But after you write dy dx, check again. Because we are using dy dx to solve question. So after you write dy dx, check again. Yes, this is homogeneous because x and y is double, the 2 degree. You take a multiplied by b. This one AA, this one BB, also 2 things, also two unknown. So this one is homogeneous. So once you've done the first steps and is homogeneous, next step also the same. You copy this question, this answer, right? You don't need to think one, just copy this one in your answer. You get 1 mark there. Y equal to Vx, dy dx equal to V plus Vx. Okay, you write this one somewhere in your answer. After these steps, you get 1 mark. Okay, next step, eliminate your y. After this step, eliminate your y in the equation. How you eliminate? Substitute, no? Substitute y equal to Vx inside here. After you inside, substitute this one, then you rearrange. After you rearrange, you get only V inside. Here and there, you arrange here and there. You simplify, you get this form. After that, you get this form, compare side by side, left the blue color and the green color. What is your V? What is your x dv dx? So if you cannot see clearly, you just put them together. V plus x dv dx equal to 1 plus V squared divided by V. Our purpose is to get what is V. Okay, our purpose is to get what is x dv dx. What is that? We want to get the x dv dx. So you rearrange, put them together, put x dv dx one side, and then the rest you arrange it accordingly. You rewrite the equation together. Again, the purpose is to get x dv dx equal to what? This side will be changing in the test or final exam. So don't worry about that. Just focus what you want. What you want is x dv dx equal to what? Normally right hand side is v only. You will see v only. Okay, 1 over v. Then after that, you rewrite the equation. dv one side, dx one side. Okay, you rearrange. You put v one side, dx one side. So v, this one to left hand side, this one to right hand side. So v exchange position. V divide, it become multiplication. X multiplication, left to right become division. Put in this form, v one side, x one side. Again, when you see dv dx, what you do integration. You do integration. Don't need to think. After this one, automatic. You see dv something, dx something, integration. And this one, be careful. Integration x dx. This is integration v dv. You will get v squared divided by 2. I'm not going to explain why this one become this one. This one, Nizam expert, you get ln x plus c. Again, remember how to get c. Use back the given value, x and y. And then ask yourself, hey, what is v? How do I get v into y and x? Remind yourself, you already substitute y equal to vx. So rewrite this one in terms of v. Okay, v equal to y divided by x here. After that, substitute value, you get your c equal to 8. Substitute 8 inside here, you get the answer. Okay, so this is how you write. So again, when the question asks you, add one more statement here. When a question asks you, give solution in y, then this is the answer. You need to write in y one side. If the question asks, give your solution in y, and this one is the answer. Okay, so with this, we end our lecture today. I end the recording. Any question? Any question?